Okay, so thanks everybody for joining tonight's exclusive MagnaClean HP webinar. If you have any questions along the way, you can unmute yourself or there is a Q&A box. So please ask questions whenever. Feel free to interrupt us. We're pretty easygoing here at AD. Before we get into it, we'll just do a few introductions. So I'm Antonia Aldridge. I'm the North American Marketing Manager and Eastern Canadian Sales Manager for AD. I've been with the business for just over 5 years, and I think I started at a similar time to you, Colin. Do you want to go next?
Yes, good afternoon, good evening, everybody. So I think we've been at AD about 8 years now, Antonia.
Oh, you have? Okay, that's
Yeah,
different.
so time flies when you're having fun, you see. That's the key thing. But my role is obviously to support contractors and anybody on AD products, how they work, why you want to fit them, why do we need to get them in the right positions. And I'm an ex-contractor myself, and I'm afraid I just can't get it out of my system, Antonio. You know, once it's in there, it's there forever, I'm afraid. So, but look forward to having a good chat tonight, and got some really exciting, innovative product to show the team today.
Jamie, Jackie? Let Jackie go first.
Hi, I'm Jackie Schrock. I am the VP of Sales for North America. I've been with AD for almost 3 years, but been in the hydronics industry for a long time. I won't tell you how long. So happy to be here. I'm really excited you guys all and ladies are all able to join us today.
Real quick, Eastern Regional Sales Manager, Jamie. Been with AD, this is my 3rd year as well. Started just after Jackie, and been in the industry not as long as her, but over 20 years now, 23 years. So looking forward to learning more about this product. So I'll shut up now.
I don't know if Doug is on, but we also have Sarah. Sarah is not on video, but Sarah, I don't know if you want to introduce yourself here.
Hello everyone. I'm not on video because I am, like Colin, I'm actually in the UK and it is nearly 11 p.m. at night in the UK and nobody wants to see my face at this time of night. But I have been working with AD for almost 2 years now, and I am very, very lucky that I get to work with this fab North American team and Antonia on a daily basis. So yeah, we work together. And if you guys ever get any communications or social media stuff, it's usually from Antonio or myself.
Okay, let's get started. So firstly, we're going to talk through the root causes of low temperature system issues. So whether you're the end user, the contractor, the engineer, our end goal is to make sure that system is running as efficiently as it should be, is lasting as long as it should, and is also performing how it should. But there's typically a couple of things that get in the way of that with a low temperature system. The first being corrosion. Now, corrosion occurs when oxygen enters the system and mixes with the metals and the water. And it can never be stopped. It can be counteracted and slowed down, but it cannot be stopped. So the clock is always ticking in these systems when it comes to corrosion. And then in low temperatures, we also have bacteria growth. So bacteria multiplies rapidly in temperatures between 4.5 to 60 degrees C or 40 to 140 F. So perfect breeding ground for bacteria. And bacteria can also lead to corrosion. And this form of corrosion is called pitting corrosion. So tiny pinholes in system pipework, for example. And again, that will allow more oxygen to enter the system. So we're seeing more and more corrosion as an effect of that. And just an interesting stat here from a company that produce monitoring equipment for bacteria. they found that less than 1 millimeter of biofilms in a heat exchanger can result in up to a 30% loss in heat transfer. So that's huge. Just a tiny amount of those biofilms on the surfaces can cause huge losses in heat transfer. And we really want to ensure that we don't get those heat transfer losses because we want to maintain the efficiencies of that system. And just in case you're not sure what biofilms are like a slimy texture that coats on the surface of components and pipework as a result of bacteria growth. So you may hear us referring to biofilms throughout this training session. And it doesn't take long for corrosion to cause damage. I'm going to play this video here. It doesn't have any sound, but I have got a quick question for you all. I want you to have a guess at how long this system had been installed for based on the corrosion that you can see inside the pipe. So if you can shout out on here or even type it in the Q&A box, give us some ideas. How long do you think? Let's see how quiet or loud our audience is here. Any guesses?
It's about 10 years.
Okay. Anybody else?
Piping looks good. I'm going to say 2 years.
Okay.
Can I have a guess, Anton? I'm going to go 5 years.
Colin, the guru, that had been installed for just less than a year. So that was found by George the plumber, very well-known contractor in the US. So yeah, it just goes to show how quick even a low temperature system with just copper and PEX suffers from corrosion. And we'll talk more about the other factors that cause corrosion, because even a system with just copper and PEX piping doesn't necessarily mean that that's the only type of metal on the system. So I'll talk about that in a few minutes. But we mentioned oxygen. The second here is pH. So pH level should be between 6.5 and 8.5. Anything below 6.5 is acidic, and that can corrode any metal in the system. And anything above 8.5 is alkaline, and that can start to strip the likes of aluminum in the system. Now, talking about those metals, it's not just the pipework that we need to worry about. We've got all sorts of different components on that system. We've got the boiler, the manifold, the expansion tank. We've sometimes got mixing valves, elbows, and these are all different metals. Now, those in themselves can cause a reaction in the system called a galvanic reaction, and that in turn causes galvanic corrosion. So your most noble metals in a system are your yellow metals, so brass and copper. Least noble are stainless, aluminum, cast iron, and like I said, even just a mixture of these metals in the system can create that reaction and the corrosion. That's why it's so important for us to look after these high efficiency systems. I don't know if you want to talk to that a little bit, Colin. I see you nodding your head there.
Yeah, no, so Antonio, really good. I think with all these different metals in there, you know, what a cocktail we're putting together. You know, I think of a combination, and I think one of the key things, obviously, with oxygen in anything is an accelerant. And again, all of a sudden, I can't believe, you know, 12 months and that system is in that condition. It goes to show if it's running inefficiently, it will just continue to roll at a rapid rate. And obviously, the running costs of that system, well, they can have been running because look at the state of those pipes. How can we be moving the water, etc., to the right places? So, yeah, I think for me that understanding that a combination of all sorts will create a real nasty cocktail, and we've got to make sure we can control it and look after it.
Yeah, absolutely. We've then got chlorides and coppers in the system. So these are aggressive ions, and just like the bacteria growth, it can cause pitting corrosion. So again, those tiny pinholes that will eventually lead to system leaks. We've then got other debris in the system, such as fluxes, especially upon a new installation. It's vital that we clean those fluxes out. This type of debris can lead to erosion corrosion. It's a term that I love to say, erosion corrosion. And then, of course, I've mentioned lower temperatures and that bacteria slime, but glycol, interestingly, is also a factor that leads to corrosion. So glycol degrades over time. A glycol with a shorter shelf life or no inhibitor in it will degrade quicker. And as it degrades, it becomes acidic. So not only, again, is it attacking those metals in the system and causing corrosion, but also bacteria feeds off degrading glycol. So you're going to see more bacteria slime build up in those lower temperature systems as well. And then inhibitors, it's really important that you consider what type of inhibitors are going into a system. So bacteria also feeds off nitrates, and there are some nitrate-based inhibitors out there. Inhibitors do deplete over time, and that's why inhibitors need to be topped up. But if there's magnetite, which I'll talk about in a second or two, if there's magnetite and bacteria in the system, those nitrate inhibitors will degrade quicker. So the type of inhibitor that you want to be dosing into a hydronic system are molybdate-based inhibitors. And then last but not least, magnetite, also known as black iron oxide. You might see it as black water, black sludge. It's a #1 contributor to hydronic heating system issues. And as I said, it's a result of oxygen that has got into the system. We're then dealing with the oxygen issue either by adding an air vent or an air and dirt separator. And as that oxygen is removed from the system, this browny, orangey colored sludge then turns into this black iron oxide, and it can be really damaging to the system. And I'll let Colin talk through some of the effects of that.
Thanks, Antonia. So, the combination of a sticky biofilm with magnetite together is pretty serious a combination. With the components we have in a lot of the especially the heat pumps and the high efficiency boilers now are such small waterways, such small controls. Any form of build up around these areas will affect the performance, and all of a sudden, we're not going to be able to get that performance right. The unit's not going to come on when it's required because the paddle's not moving over, and especially with circulators and pumps, that film in there, Antonia, remember, we've got to move that water at a good high flow rate to make sure we get as much energy out of that lower temperature water as we can. And if we're starting to get issues within that system there, we again, that's going to affect our performance. And again, seals breaking down after a period of time, a short period of time, is and again, all these components, Antonia, are expensive. They may seem small, but to get to them and strip them out and replace them, you've got to get through to the back of the unit, and all of a sudden, expensive, high cost to the homeowner, and they don't want that. They want peace of mind with, the winter season is going to be upon us very, very soon. I can't believe around September's around the corner. So, we want to make sure that everything's in a good condition and we're running sweet, because you can see on some of the pictures there on the right hand side there, the fouling that is occurring is that's only going to be a bad news for a boiler. I noticed Tracy's got there's a question.
I saw that as well. Yeah.
In regards to George's system, what was that filled with? Just standard water makeup? Like there was no external corrosion on the piping?
No, that was just standard water. Yeah.
and any water test afterwards?
Well, George, after that, he did do a test, yeah, and he did install the MagnaClean Pro 2 XP. Obviously, ideally going forward, that type of system you'd want to install the HP on, and we'll explain why once we get onto the HP section. I was going to mention as well, the ECM pumps have tiny magnets in them. And magnetite is attracted to magnets. It's why we use magnets, you know, at the core of our filters. And as you can imagine, the magnetite is attracted to the magnets in the ECM. So that's why we see failed ECMs, just like you can see in this image here. So as Colin mentioned, we're dealing with much smaller waterways now, which means everything's getting blocked easier. And I mentioned about those dissimilar metals, so much more intolerant to pH imbalances. And of course, this leads to poor heat transfer, efficiency loss, and increased utility bills for the end user. Colin, I know you've spoken to me before about signs of scale in a system, and maybe you can talk here about some complaints that you might see from homeowners if corrosion or bacteria or even scale has built up in those systems. So what will homeowners typically experience?
Right. Well, so I think one of the most probably the most annoying one of the most annoying problems is obviously a lot of noise. Suddenly that unit down in the basement is suddenly rumbling and unbumbling, and you think, what on earth's going on down there? And that's a sign that something is, you know, is causing an issue. The heat is not getting away quick enough, Antonio. Remember the lime scale, the biofilm, we're creating that duvet of almost insulation inside the unit. So the heat transfer is not happening quick enough. So all of a sudden, we're like all of us, we don't get the coat off when it's a nice hot summer's day. We get hot and bothered, and all of a sudden, you know, we're not very not very happy with the way things are going. So obviously, you're naturally going to notice issues regarding the temperature of your water. So again, the key thing, if you're not transferring the water into your especially your domestic hot water, you know, it's not warm enough, so suddenly that affects the homeowner and you know, the bathing and washing, etc. You've also then got obviously your baseboards, your panels. Suddenly you're starting to feel cold spots, maybe some pyramiding in the middle there, where suddenly the magnetite is building up. And you remember, for you know, a few months of the year, there's not a lot of water movement. And again, I think suddenly that breeding ground for the micro biological growth that we talked about, plus the magnetite, suddenly everything's just sat there, and it gives it a chance to create its little house as such. So, you know, it's all of a sudden we start to feel those components aren't working as hot. So what do? We go and turn the unit up hotter, expecting the system to get hotter. That's not going to happen, guys. What is going to happen, your fuel bill is going to go, whoa, you know, and that's certainly what the homeowner will start to notice. And again, it's just the fact that, you know, we want to have our heating and hot water system to be on when we need it, and without having to phone somebody up to say, look, hey, I can't get this to come on this morning. the pressure's already on from the rest of the team in the house, you know. And I think, you know, the homeowner will certainly start to notice maybe, like I say, certainly a lot of clunking and clanging, components getting very hot. Antonia, you spoke about that, your circulator. One of the key things there is that magnetite gets into that unit. All of a sudden, that circulator casing will get very hot. The resistance is in there, and all of a sudden, that's going to break down one or two of those seals very quickly, as you can see there. So all of a sudden, issues are all everywhere in the system. So, you know, certainly, I would always advise homeowners get the system on before the winter starts. Make sure what's going on. Get the contractor in to see what's going on, because you know there's been a few months where nothing's been on, Antonio.
Yeah, exactly. Just before we move on to the specifics of the HP, I just want to talk about magnetite a bit more. And I think it's really important to understand the size of these very fine particles. So to give you an idea, the average strand of human hair is 70 micron in diameter. Naked eye visibility is 40 micron in diameter. The average magnetic particle ranges between 2 to 8 micron in diameter. So they're very, very fine. And that's why sometimes if the magnetite has only just started to build up in the system, it's not visible to us. And that's why we preach here at AD that finding the root cause of any system issue, apart from the obvious, filled components, or like you said, the components feeling hot, Colin, we really need to test that water because it doesn't necessarily mean that it is clean just because it looks clean. We can't see pH levels either, so it's vital that we keep on top of that testing. So before we get into the details of the HP, I'm just going to ask if we have any questions here. I don't think I can see anything on the Q&A board, but if you do think of any questions, please don't be shy. This is a new solution that we're talking about. Not many brands have talked about the effects of low temperature systems as of yet, so we're very aware that this is going to be newer information to most of you, so please ask if you're unsure of anything. All right, MagnaClean HP, very exciting. So 4 key points here of, oh, did we hear somebody there? Am I hearing somebody? No? Okay. Thought somebody shouted out. So what makes the MagnaClean HP dedicated for low temperature systems? So firstly, as you may know with our other residential products, we have a large magnet in the flow of water because we're dedicated to that magnetite capture. So the magnet for us isn't an afterthought. As I mentioned, those magnetic particles are so fine. That's why we need to use magnets to capture them. So that's why we make the magnet at the very core of our product. You'll also see on the bottom point here that servicing is made really easy for the contractor. So again, we're placing this on the return before that heat source, the heat pump or the boiler. We want to protect any magnetite and bacteria that circulated around the whole of that system before it hits the most expensive component, which is usually the heat exchanger. So ours is a dedicated magnetic and non-magnetic filter for the return of the system. It also comes with its own isolation valves and the mesh is removable. I'll talk a bit more about that in a few minutes. But we also have a dedicated cycloflow technology. I'm just going to skip to this page here. So the cycloflow technology diverts water for maximum capture. So we actually have a piece of material on our inlets and outlets that forces the water in a vortex motion. So what happens is the water will go straight down into the bottom part of the canister first, where we can capture that non-magnetic bacteria slime. And the water will work its way up around the magnet before exiting. So we're just maximizing that capture, and that is completely unique to the AD product. In terms of details, for those of you that are familiar with our Pro 2 XP, it comes with 1-inch compression and 1¼ inch NPT connections in the box. You don't need to buy the NPT connections separately, it's all in the same box. It has a 21 GPM flow rate, max working pressure of 87 psi, and you can see the operating temperatures there. They are bidirectional, however, this one is not. So this is directional, and there are arrows on the product that show you where the flow in and the flow out should be. And again, this is to ensure that the cycle flow technology is working as best as it can. So before we go into the features and benefits, Colin, I know you've got a box there, and we'll just talk you through what comes in the box. I'm just going to remove my blur on my background so you can see better. There we go. It's a nice compact box. I'll open that up here. So the filter will sit in this section here, and then we've got a separate box where you get the valves, the isolation valves, 1-inch compression, the 1 1/4 inch NPT. There is a tool, a spanner in the box that allows you to service the filter really easily. So there's a section that allows you to turn the valves really easily. And also remove the bottom part of the filter, because we are servicing this filter from the bottom. And also included in the box is your INS guide. So we're using QR codes now. So once you scan that, it will take you to the website with your INS guide on. And the filter does come with a 10-year warranty as well. So we're really backing the quality of our product with this warranty.
Antonia?
Yeah.
I'm only seeing your slide. Do you have an actual working unit?
Yeah, can you not see me on the screen?
Nope, only seeing the slide from the PowerPoint.
I'm wondering whether that's a setting that you've got on Zoom. Can anybody else see? Can anybody else see me or Colin?
Yes, I can see you anyways, Antonia.
Yeah, I can see.
Yeah, seeing you.
When you
Yeah,
speak.
try and open your other eye.
Okay, so it's just Jeff.
There you are.
Are you got me now?
I found you. Okay.
Perfect. Does anybody else have any questions? I don't know whether I can see everybody on here. Jackie, I'm going to ask you to keep an eye on the Q&A box just in case.
Yes, I am. No questions yet.
Okay, perfect. Pressure drop. So we get virtually 0 pressure drop with this filter, even when it's full. And again, that's because of the cycle flow technology, but also the way that the magnets are aligned in the rod. So we align them in a way to ensure that the magnetite collects in a ripple effect that enables the full flow. Colin, I don't know if you want to.
Yeah, so what I think what I was going to say, if I may, Antonia, I've got my little unit here, guys, and I just wanted to see. I'm wondering if I can. Yeah, I think I can, without blinding everybody.
You might want to do it the opposite way. Put the light the opposite way to the front.
Oh, so yeah, so hey, so what it was? Can we just see that half moon there? So basically, guys, you can see that when the water comes in. So Antonia mentioned there is on the bottom here an arrow. Okay, I don't know if we can see that there. So the flow of the water coming from the system goes in at the bottom here, and as it hits that baffle, it's, remember like on this drawing here, we can see it sends the water down. So the water now has to go downwards through the gauze at the bottom. And again, let me just show you at the bottom here, we can see our non-metallic capture. So the water has to go through this component here, which obviously, remember, like Antonia said, talking about that biofilm or those non-metallic components that aren't going to be attracted to our magnetic core, which is this part here with our magnet in our dry pocket here. That's magnetite, but those other components we need to make sure go through there. And if I may, Angela, I just want to take that gauze out there. Now, the gauze itself, you can see, is stainless steel, and it's really, really clever that, you know, it's got a waves through there. So it's like almost like a fishing net, that when that water's passing through there, that any sort of sticky algae is going to get captured in there. It's going to stop it going on through into the boiler and the expensive components. Now, a lot of heat pumps out there, guys and girls, have strainers in them to stop rubbish getting into the unit. The problem with the strainer, it will fully block. The beauty of the AD HP filter with the cycloflow technology, it will continue to protect, but once the filter is full, it will also allow passing. So it's not going to stop the system working as such. But the beauty of this is all the components can be easily cleaned as well, Antonia. So, you know, I think that's another key part. And I know we'll go through a few little tips there, and I've got one or two little items here I wanted to show you, but also the isolation valves. I think you mentioned earlier, one of the key things for any contractor is the fact that these isolation valves are nice and easy, quarter turn action, on and off, clearly labeled green and red, so you know which way they are, so you're not going to get any concerns about am I on, am I off, etc. So I think that's really, really important as well. And again, obviously, at the bottom of the chamber, I think you're probably going to show Danny, Antonio, but the bottom of the chamber here, when you service the unit, the beauty of this is there is a drain off facility. That means you can drain the whole chamber out. Let's just put that back together like so. So you can isolate the machine, the filter, and then drain all the water out of this unit. So when you remove this bottom component for service and maintenance, and again, Antonio, you mentioned how important that is every year, or, you know, maybe a couple of times a year possibly, to service it and make sure it's in a nice and clean, to make sure we keep that high efficiency. Because if we lose the flow rate into some of these low temperature systems, Antonia, is going to affect performance quite considerably. This is the beauty of the cycloflow HP filter. It works so well with these high flow rates. And I think it's 21 gallons per minute, which is good. You know, and you'll find a lot of the heat pumps out there require that high circulation rate. Otherwise, they will not work properly, Antonia. So the way systems are working now are changing, and they're requiring a combination, not just magnetic capture, they're requiring non-metallic capture. We've also got one of the key parts, which I love about this HP filter. Again, it's innovation. AD built its name on innovation. And the guys and girls in our R&D department have put some clever time into this. And, you know, even to the fact, Antonio, I must mention, is at the top here, and again, you're probably going to go through that, is the dosing point here. So basically, guys, on the top here, we have an air vent. So you always have your vessel upright so you can release any air out. Because we know if you have air in any form of canister, it will be noisy. Okay, so we always have our vessel upright. So, but also you can remove this air vent component. You now have a pouring port here, and not only that, the team, we decided, look, hey, we don't want to get messy chemical everywhere. We got a little drip tray, you know, so when you're pouring your spooky,
Colin.
Got a little bit of MC3 always handy. You know, when you're pouring your chemical into your filter now, you've got a dosing pot that's really accessible and easy as well to use. So all of a sudden, we're getting protection, we're getting ease of service and maintenance. Suddenly, we've got a unit here that's going to be pretty important. And I just wanted to show one also thing with the valves, Anthony, when they are connected on there in the kit.
Yes.
If I may just run that up, you can see how easy that's gone up. You know, everybody, that's gone nice and easy. You're not going to cross thread that. But in the bag, we have a set of collets. Now, I don't want to see these being chucked away. These have a reason, like everything. You pop that over there, and all of a sudden that collet is on there now. So we know that the union is inside the filter. Good. Now, imagine you need to service the unit a little bit later on, 12 months later, and you want to take it off and do it maybe outside or, you know, away from the boiler or etc. With this collet on, Antonio, when you undo the nut now, the collet stops the nut from going back. And that means basically it will ease the valve, the filter forward off the valve. So basically it will come off nice and easy, because we have a double O-ring seal here that wants to grip. And if it's been on for 12 months, 18 months, it won't want to let go. But that's collet will allow you to get that off there. And all of a sudden, then we're ready to go and obviously service and maintain and check everything and make sure we're in a good place.
Thanks for that, Colin. I just want you to show us one more thing as well. I know what can happen with the valves if the nut isn't pushed back to begin with. Sometimes contractors are putting the valve on wonky, and sometimes it can even get cross-threaded. What you want to do is pull that nut back before you put the valve in. You should be able to hear it. You hear that when you push it in? And then you can tighten the nut on.
You should be able to run that up, Anthony, exactly like you've done. Again, like Anthony said, you hear that click of the union going in, and then that nut should run up smooth. If it's not running up smooth, because a nice strong inch threads on there, you know it's not quite in line. So let's not try and struggle with it. And that's my say, make sure it's home, run up, collet on. We're in a good place.
Perfect, thanks. Just another couple of features here. So on the air vent, we do use double O-rings, just extra durability. If one fails, it shouldn't, but if it does, you've just got extra peace of mind with that. We also always use EPDM seals on our filters, and they are completely compatible with inhibitors. There are some products on the market that use Viton seals, and they are not compatible with inhibitors and can degrade. Colin, I think you've already spoken about these points jumping the gun, but I'm loving it. I don't know if you just want to show how those valves rotate. So I've only got the bottom one on here, but you'll have the other one going up this way. So you can rotate them for ease of installation as well.
So the key thing about that, Anthony, is the pipe work can go wherever it likes. As long as the canister vessel is upright, the pipe work can go all the angles that are going to help the contractor get it into a nice, easy position for install and obviously regular servicing. Right,
you already covered some of my tips and tricks. The collets we've covered, but I really liked this one that you mentioned yesterday, Colin. So go ahead, the good old toothbrush.
Right, so guys, you might say, what toothbrush? So first of all, rule one, we never chuck a toothbrush away. So remember, we've come to service the filter. We've come to service our HP filter. We've seen how easy that is. You know, quarter turn action valves, nice and easy, clearly staying radiators off, etc. Now, when we take the magnet out of the bottom here, obviously the magnetite then can be swilled off and removed from that core. But the filter part here, the gauze here, the stainless steel gauze, needs a bit of a clean. So basically what I would say to you is I would advise possibly maybe some gloves. Just remember, we are removing some bacteria here, and so be careful. And as always, an old toothbrush should always be in the toolbox. And basically with the hot water, we can get all that sticky slime and algae out and get it cleaned off. I have to say to you, make sure you don't use it again. Make sure you don't mix the brushes up. But, you know, honestly, I'll tell you now, this is such a great way, because the film, it's sticky. And that hot water on there, swilling it off, you'll find it a massive little tip for you there, guys, is that toothbrush will become invaluable.
Love Colin's tips. Another tip from me is using the test strips. We've got on-site test strips and also our rapid test stick, which is a little white stick that has our magnet on the end. It's a great show and tell tool for when you're explaining the impact of magnetite, corrosion, bacteria on these systems, and really how to get the homeowner invested in the solution and having the filter installed on their system. So using tools like that is really helpful. Also, a lot of boiler manufacturers are now aware of the effects of poor water quality, and they have started adding in clauses in their their warranties, they've started voiding warranties for signs of sediment, magnetite, lack of water treatment, and lack of proper maintenance on those systems. So again, a tip for you guys when talking to homeowners is show them an example of that warranty condition. I think that's, proof in itself that the homeowners should be protecting their investment. And we as contractors should be protecting our reputation by offering it as well. Any tips, Colin, when dealing with homeowners?
Again, the homeowner is the key person to all of this. We have to make sure that they realize that once they've got this filter on there, I think for me is that they're going to be really key and happy that they're going to be using not excessive amounts of energy to warm the house up. And I think, when you go in there, you're right. The HP filter is going to give you the best of both worlds of protection. Non-metallic, which is that low temperature water, which we know is coming, and it's a different sort of issues that you get, but combined with that magnetite as well, the best way to get the best of both worlds as such is the HP filter with its unique techniques have there. But the homeowner, like you say, Antonio, needs to be made visual. You need to show the contractor needs to show the homeowner what is going on in that system. Out of sight, out of mind. It's like everything. We all are the same. We don't do anything about it until it goes wrong. Let's show the homeowner, and suddenly we get there before it becomes a major issue. And like I say, Antonio, your rapid test piece there, I think is always a massive tool for contractors to be using.
Yeah, and I think even just sitting down with the homeowner and giving them a bit of your time and explaining how this all works, the impact on the system. You don't even have to go into too much detail, but you can really show your expertise by doing that, and you're building trust with the homeowner.
I think you can also compare it a little bit to, you buy a very expensive car and you maintain it, and you're going to change the oil. If you don't change the oil, you're going to have issues.
Yeah, exactly.
Basically what the filter is for you, right?
Do we have a Q&A here? Are there other sizes coming? No, this is the only residential side, Tracy. But you have sort of covered one of my frequently asked questions I was going to cover towards the end, but I'll cover it now. So commercially, once you start getting into commercial sizes, you'll want to be quoting the CMX. I'm sure you've heard about that product, and I'll talk about that in a few minutes. One other frequently asked question we've got here. So what is unique about the stainless mesh? Does it offer antimicrobial properties? We got asked this on one of our rep training sessions, and I thought it was quite an interesting question. I know we've talked about the benefits of the stainless steel. So the reason we use stainless is to prevent the mesh itself from rusting, so it is long lasting. Usually copper is an antimicrobial property. However, we don't want to use copper in our filter. Just like our filter isn't made out of brass, we don't want to add more of those dissimilar metals to the system, and we don't want to cause more of that potential corrosion in the system. But also we're looking to attract the bacteria so that we can capture it. We're not looking to repel it. So that's another reason why we wouldn't use an antimicrobial property on our filter. So I thought that was quite an interesting Q&A there. Where to install. So just like our other residential filters, we should be installing before the most expensive component. On a snow melt system, like I mentioned, you're probably going to get more into the CMX side of things, and you'll want to protect both that snow melt loop and the boiler side loop as well. So on those types of systems, you might want to install 2 filters, one before the heat exchanger and one before the heat source. quickly going to cover best practice solution. We're not going into too much detail on this today because we really wanted to nail down on the details of the HP. But as I mentioned before, we should be testing the water, and that's the first and key stage. The second stage is to clean and flush, and our MC40 is the best type of cleaner to use in a low temperature system. So this is an acidic based cleaner. It's going to work better at lifting and removing that bacteria slime. So this cleaner is designed to lift and dislodge any of that existing magnetite, limescale bacteria, ready for it to be flushed or drained out of the system. We have a MagnaClean flushing unit that works as a bypass unit, so you can clean and flush while the system is on. And as Colin has said before, we all work a little better with some heat on our back. And so if you can keep a cleaner running in a system while the system is on and the water is hot, you can actually double the reaction time of a cleaner. So it's a much more effective and quicker way to clean and flush a system. We've then got step 3, which is to install the filter and dose the system with inhibitors to provide that long-lasting protection. And an interesting fact, I mentioned it earlier, magnetite actually uses up inhibitors in the system. So the more magnetite you have, the quicker your inhibitor is going to deplete. And that's why inhibitors alone do not protect a system. We need the magnet to capture the magnetite, and we need the inhibitors to buffer or balance those pH levels. So as long as you've got enough inhibitor in the system, your pH range will stay between that 6.5 and 8.5. And it's also providing a coating, a layer of protection on all those surfaces to prevent any future scale and magnetite from building up. And then, of course, lastly, let's not forget maintain. Let's not just install these filters and dose the system once with the inhibitor. We need to go back and we need to make sure we're on top of the maintenance. Any filter will only capture so much until it reaches its capacity. So that's why we need to keep on top of this. And as I've mentioned, inhibitors deplete over time. So testing with our test strips, the inhibitor levels, and topping up when necessary. So Tracy, going back to your question on other sizes, so we have our MagnaClean CMX, which is a magnetic and non-magnetic side stream filter. So just quickly, so you're aware of it, we can send further information after the session if you'd like to know more about it. But it comes with the magnet, which you install first to capture the magnetic material in the system. And then you can combine with our non-magnetic. So the MIDI and the Nano, they have cartridges. The larger size, the Maxi on the right, has a bag filter and stainless steel basket strainer. And the 2 larger sizes also act as a pot feeder. But like I said, if you'd like more information on that, please just let us know. And then last but not least, we do have a quick digital contractor guide that just talks you through the information that we've discussed today. So how bacteria grows in a system, the key features and benefits of the HP filter. Your rep, your local rep has access to this, so please ask them for a copy. And that is the end of the session. So thanks again for everybody jumping on. Colin, thank you very much for jumping on so late.
Yeah, no,
Any other question?
My pleasure.
Did you say we've got a question, Jackie?
Yeah, Kent Green, on large commercial systems, is there a way to have a remote test reporting capability? Great question.
Does anybody want to answer that?
Just repeat that again, Jackie, just so I've got that full.
On large commercial systems, is there a way to have a remote test reporting capability?
As in, so if the filter is starting to capture and get to its full limit, obviously there's a pressure drop within the unit, so that can be monitored back through. Yeah, there.
So you can add a gauge, I guess, on the CMX.
Yeah, we do have a pump side streaming unit that maybe no.
No, but on the CMX MIDI and the Maxi, there are two drain points, and on one of them you can add a gauge for that, so you can see when you're seeing that pressure drop, and that will give you an idea of when the filter is getting full. But really, on commercial systems, it's a monitoring process. We all know that commercial systems are maintained more frequently anyway, and typically, Ken, you'll see pop feeders or even just your typical standard cartridges already installed on a system, and that's the perfect opportunity to replace those with the CMX. The reason why contractors are changing those cartridges so frequently is because they generally only capture down to micron sizes of around 30, and that's why we incorporate the magnet in ours to capture the magnetite as well. So once you've captured that magnetite, the contractor will see less swapping out of those cartridges. But yeah, there's no remote reporting capabilities at the moment, but like I said, you can add a gauge to those products. I hope that help answers.
Yeah, and then the other question is, can you please share this video?
Yeah, this is recorded, so we will be sending a follow-up email with the recording link. Any other questions?
What can I see?
Are they available now?
Yes.
Good question. Yeah, we literally have just got them into stock, so available. Woo-woo.
Woohoo, yay! I'll sell them tomorrow.
All right.
Love it. Thanks, Mary.
That's perfect. We just got them in, so that's great.